I'm going to get started with some Liquidsoap updates. I was looking at the presentation from last year. It's going to be much less technical. It was crazy last year how technical I got into. But anyway, my name is Romain. I'm with Sam here. Sam is hosting that conference and has done a lot of the groundwork to make it happen. We've been developing Liquidsoap together for a long time, and we used to have also David with us. Yeah, and I'm going to talk about everything. So the program. I'm going to talk about what happened since the last workshop about a year ago. Then we're going to talk a little bit about the roadmap, which is basically what we want to do in the future. And then we'll have some question and discussion. And as I said, when I did the presentation last year, we were in the middle of a lot of technical things. This year has been slightly different, and so it's going to be a little bit lighter, but for good reason that I'll explain. And I'm hoping that at the end I have time for questions, because I want to get some input. I think it's a very unique chance that we have everybody available to talk, and we can learn a lot from you. So let's get going. Yeah, so last year when we did the presentation, we were close to the 2.3 release. In all reality, we'll see the date, but the presentation was in June or May, I think May, and the release was in November, so close as in 6 months away still. But 2.3.0, we call that X, is the cycle. It was a very important release because since the project started, we had been stuck with certain technical decisions from the beginning that we were realizing were dragging us back and were very hard to change. And some of the things we did for that release were very much in-depth and completely rewrote internal and very central core part of the software. So the first thing we did was to rewrite the streaming loop. And I presented that extensively last year, so I'm not going to do it again. You can watch the presentation perhaps if you want. But essentially, the core of the application is how we do streaming. So you constantly have to create media from your sources, prepare it, and send it to your output for streaming, Icecast, YouTube, whatever. And so that's the core of what we do, essentially, is the streaming loop. And so that was entirely rewrote. And if you do that wrong or right, or if you change certain property of it, it impacts everybody. And we'll talk about how that has actually impacted the compatibility with OCaml5 in a minute. We also rewrote the clock implementation. So as part of the streaming loop, as you know, there is a loop in it, and loop meaning that we do it over and over and over and over and over again. And the things that do it over and over and over and over is like a clock. We call that a clock, which is the abstraction for maybe like a little timer that says, I need to prepare some content, send it, prepare some content, send it, and check if we're like on time. And there's a lot of complication with that. For instance, a sound card output would control the clock, but a file will not. It's complicated. But that too had evolved organically from many years ago and was never completely rethought from scratch. So we redid that from scratch as well. And those two changes were pretty big. And so that makes up for a release that, as you see, needed a couple of time to mature, a couple of iterations. The one thing we were not able to do is OCaml5 now has a super good or interesting support for multi-core support and concurrency, where you can like run your video encoders in parallel and stuff. We were not able to use it because we were not able to move to OCaml5. And I'll talk about that in a minute. Also, a lot of people were complaining about how long it took to load a script after years, because our standard library, which is all the tools that we offer to users, was growing bigger and bigger and bigger, and the complexity of the language was growing also bigger and bigger for good reasons and good things, but it was taking more time and memory. So we addressed that by adding a caching layers, which means that the standard library is pre-computed and it's very fast to load. And if you cache your script, it's also very fast and reduces the memory footprint. And so I think that was pretty successful. And the other thing we did, and I think I'll present something about that later because we have a 30-minute slot that just opened, is add developer tooling so that using Liquidsoap is nicer for everyone. So all that was done. We finally released 2.3.x in November, and then, well, we still have to update the Liquidsoap book. I'll talk about the book in a minute, but we are very well aware that a lot of people joined the project because of the book, and it's a very important source of truth. It was written around the time of 2.0, and there are some things that are outdated, and we definitely want to address that, and I'll talk about it in a little while. So yeah, that's the timeline for the release. November was the main release, and then we've done 3 bug fix releases, February, April, and May. And I would say essentially I would consider the 2.3.2 or 2.3.3 fairly decent, stable production release. The previous one were not bad, but we've addressed some good issues. The 2.3.3, the biggest difference, there was a seg fault in some very last minute C code for LUFS computation. If you don't use that, 2.3.2 is probably just as good. And that's the one, the 2.3.2 is the one that's currently scheduled to be released in Debian. So pretty happy with that. That should put us in a good spot for the next Debian release. But essentially, the reason there has not been a lot of technical work happening since then is because stabilization takes time. And if you really want to address all the bugs and all the things, you can't really at the same time add a lot of crazy features because they basically add some stability issue. Typically, this LUFS C code was introduced in 2.3.2, and created a new issue that had to be fixed in the new bug fix release. So yes, we're just slowing down because there was some major rewrite, and we want to make sure that everybody has the time to properly deploy, give us some feedback, we can address it. Typically, we're happy to report that Radio France, our partners with Radio France, are finally running a stable release of Liquidsoap, and that's big thumbs ups. And we kind of want to like take the time for this to happen before doing things. See, we have people still updating today, so we need to be patient. And also on that, and I'll talk later, I want to give a big shout out to everybody helping TriEdge help user get details through discussions and report them as issues to us. That is extremely helpful to help us understand what's the priority in fixing things. So the roadmap is what we want to do in the future. And yes, I'm going to talk about all these things. And the first thing we need to think about is moving to OCaml5. And the reason we want to move to OCaml5 is because OCaml is the main compiler for the application. And the 5th release was done at this point about 3 years ago, probably more. And they are at 5.3 at the moment, and we are still stuck on 4.14 that they have maintained because OCaml went through the same thing as us around the release 5. They had a major rewrite of some internal things, mainly the garbage collector, and I'll talk about it. And because of that, they decided to stick around with the old version for a while until the 5 branch is stabilized and progressively make the 5 branch the main branch. They consider that 5.3 was their first like real stable release. It's not for us, and I'll explain why. They have a 5.4 that is supposed to be more suitable for us, but I haven't been able to test it yet because not all the ecosystem, the modules that we use, have been ported to it. But this is a big challenge for us because we can't stay for too long on 4.14. At some point or another, some of the modules we use are going to start being outdated. We just need to keep with the flow. But here's the big problem we're having. That's from Radio France when they did try to switch to OCaml5. It's not looking good. It's the memory usage. It went from 8 gigabytes to 24. And I'll talk about it. It's the OCaml garbage collector not being able to, the new version, the 5.1, is not able to keep pace with how we generate and handle memory. And let me show, yeah, so because of that, what we did for the last release, we started building packages and binary builds for both versions of OCaml, so that even if we don't consider OCaml5 as suitable, we are giving people the choice so they can test it and report to us, if they see any problem. So far, the only major difference is memory usage. We don't see any other backward incompatibility. So why is it that it's consuming more memory in the 5? I want to explain that very quickly. This is a streaming loop. That's from my presentation at FOSDEM this year. Basically, we take a little frame duration of 0.02 second. The CPU is our reference for time. We start at a certain time. We generate all the content we need and we send it to the output, and we mark the time that it took us to do it. If we did it in less than 0.02 second, we can sleep a little bit, and that means that we are able to generate content in real time. We're going to be able to keep pace. If you're listening to us on Icecast, on HLS, you're going to keep getting your content on time because we're preparing it fast enough. If we are taking more than the frame duration, we're getting late. That means that your buffer as a listener will start being depleted, going shorter and shorter, and eventually you'll have a buffer under and you'll run out of content. This is what you see when you see catch-up messages. We start running very fast to catch up on being late. But essentially what that means in terms of memory is that every 0.02 second we generate content, audio, video, that takes up a lot of memory. Typically, imagine that you're generating a video that's like 1080p, and there is like a video frame per frame, an image per frame. That's a lot of data. Even audio is PCM data. It's a lot, and it's constantly being generated on a very short cycle. And after we're done with the cycle, most of the content that has been generated can be disposed, can be cleaned up, because we generate it, we send it, we don't need it anymore, unless a little bit, a fraction of it stays in buffers, but that's minimal. But the problem with that is that the Liquidshop5 garbage collector struggles to keep up with this. It's not cleaning up, reclaiming the memory fast enough, and it accumulates and grows. The other problem with the GC is that it needs CPU to figure out what to clean. So the more memory you generate, the more work it has to do, and it increases your CPU usage. In a context like that, where we want to always be able to be on time and optimize our CPU consumption, this is also creating some headaches. So it's appearing that now that we've worked on the streaming loop and the clock rewrite, the next frontier, if I can say, in terms of technical challenge, is going to be to deal with that. Certain ideas that we have is like, can we move the content memory outside of the OCaml memory stack? Can we allocate that and tell OCaml, don't worry about it. We'll take care of allocating and cleaning it up. We don't need you, and you don't need to work on that. So typically, FFmpeg does a reference counting. If you generate some data, every user says, I'm using it, puts a marker, and then plus or minus, and when there's no more people using it, you know you can clean it up, and you clean it. But the problem is that when you're working with OCaml and the language itself, and I'm not going to go into details, but it's very hard to enforce a strict ownership. It's very hard to know when a piece of data is no longer being used, because we are reusing it in a lot of places. But this is kind of like the general ideas that I'd like to explore, and I would love to see if people have ideas around that. We want to simplify our API. I'm going to go a little faster. I want to have time for questions. So that's the other thing. Now that we've done a lot of internals, here's something that we've noticed, and don't worry guys, we are seeing it. Some of the stuff we have is from a long time ago, like a switch and a fallback, and it works, but we keep having over and over and over and over the same questions. How can I do a very simple thing? I want to play a random jingle at a fixed moment. I want to play a specific song at a specific. These questions happen over and over and over, and we're very much aware that this is a pain point for users. So we want to think about how we could do better. And I know that Sam has some ideas for that. Maybe during the discussion we could talk about it. But essentially, we need to better understand our user needs. And I've finished the presentation with that. Like, I think the power of our group of people using here is that we have real users in a lot of cases, and if we can understand better what you guys need, we can try to figure out the good base API that we need. Maybe Switch was not the good abstraction, because Switch right now is what drives everything internally. The fallback is implemented in Switch. But maybe we need to find something else. And what we essentially strive to do for APIs, we want simple things to be simple. Like if you want a track to be played at a certain time, you shouldn't have to write a discussion and read 3 different tutorials. That should be something pretty straightforward. And if you want to do complex thing, it should still be possible, maybe with a little bit more work. So that's another things that we want to think about for the future release. adding no functionalities, that's always a thing. So at this point, personally, I'm a little bit out of ideas at what would be the next killer functionality for us, but I'll list a couple. Native pipe wire support. It's the standard audio framework for Linux now, but it also supports Pulse Audio, if I'm correct, that we also support. So far we haven't had a big need. But is there something in Pipewire that we could get natively that could be a killer feature for everyone? NDI, I know it's a private format and people have a lot of opinions about it, but it seems also that it's a standard for intercommunication for streaming application, and a lot of pro, live streaming things use that. So I know that Liquidsoap could be probably used in a lot of professional upscale streaming situation if we had a better support for NDI. Just an idea. Whip and Web, which is the WebRTC, we want to be able to ingest, so receive a WebRTC flow like that. Typically for years we've been thinking, can we do this Liquidshop workshop on Liquidsoap? Well, the first thing we would need is probably have a WebRTC support. And Whip and Web have been standardized to provide HTTP interface to receive and send WebRTC data. And let me cut it straight. I've looked at the implementation. It's a lot of different protocols very specific to WebRTC. I don't think we're cut out to do it. But FFmpeg is slowly starting to implement it. Actually, the whip was just merged, which, even though it says ingestion with the I, actually for FFmpeg it means that FFmpeg is able to send WebRTC content at the moment. Don't ask me why. I'm not sure why whip became the next output, but it means that hopefully at some point they do the web too, which is the killer feature for us. And by using FFmpeg, we should be able to incorporate that. I hope. Finger crossed. FFmpeg is a slow-moving project, so patience is good. Yeah, and then fixing existing functionalities. We want things to work. I know that typically there are 2 reports right now about the shared encoder that's not working for live sources. I definitely want to look at this, because I think being able to do a share encoder and a distributed output, like you encode once and you send to several places, is a very important feature that more people want to use. So we want to make sure that works fine. And we want to grow our community, which is the last part of this presentation. Because one thing that has been amazing is to see everyone interacting with us. Over the years, we've had a lot of different users, web radio, national radio, streaming, stuff I don't even know is being done. And we want to grow that. The first thing is because y'all are so appreciated. It's very important for us because it really helps drive the project. I think without the community, we are volunteer-based project, and without a community, I don't think we would have the drive to do it. And we really appreciate all y'all. I wanted to put some names here, and I started getting a little bit worried that I would forget people, and some people would feel left out, so I didn't put names. But y'all know who y'all are. Everybody who's helping, who's in the chat right now, either using Liquidsoap and getting back to us, like the cool people from AzureCast who have helped us shape our release process and coordinate release, all the people helping with users, all the people giving us bug reports and being patient with that. This is really appreciated, and thank you for that. So typically we have Mr. Vito, who for a couple of years now has been really doing an incredible job at triaging issues, filing bug reports with reproduction case, being patient, going back and forth. That has helped so much. JLab, Stefan has been doing that. Other people too. Again, I didn't put all the names. I didn't want to forget anyone. The other thing we want to grow our community is, as I said, start the Liquidsoap book again, or update it. We were having an interesting conversation in the chat yesterday, because the doc is always a pain point, and everybody has different ways of learning, but it looks like the book has been a very important entry point for a lot of people, probably more than the website, probably more than anything. So it should be our priority. And I don't know how Sam feels for sure, but I think the book is a GitHub repo, and we would definitely be open to contributions. My name and his name are on the author list, but frankly, I think it could be a more community-driven project, I imagine. I don't want to talk for Sam, but so we can talk about if you all want to contribute to the book and help us make it ready for 2.3. And the last point, but I want to emphasize, that's probably the most risk at this point for the project is actually core contribution in the code. This is me, this is Samuel, this is me when I had my ICQ nickname. This is David, our founder and initial contributor. Samuel again, this is David. So you have all these commits. It's missing some of the old SVN commits, but yeah, we need to think about that. I don't think that Sam and I will be here forever, and we're here now, and we'd love to onboard more people. And what's happening in this software is what I've seen in a lot of radio projects is that most of our users are not technical users; they are radio people. They're not OCaml programmer. But how can we progressively onboard people? Is there any interest in learning the language? And we also are well aware that the code base is getting pretty big and can be scary to learn, intimidating. So we'd also love some feedback and progressive documentation about how to get into it. So yeah. Last thing is how should we keep in touch? When I'm doing the promotion for this workshop, I was trying to use email. I think email is a great thing. We haven't grown the mailing list for a while. The Discogs have been growing pretty amazing, but Discord doesn't give us a list of emails, so it's a bit complicated to get in touch and see what is exactly the size of the community. If you remember last year, GitHub linguist told us that we're too small of a project to get support for syntax highlighting, and they have a very narrow-minded consideration, which is the number of files in their broken search engine, and it's extremely frustrating. But one thing I cannot tell them is how big the community is because I don't really know. And I think it's big. I just don't know how we can gauge that. Yeah. So this is the part where I left about some minutes, and I just wanted to know if you guys had feedback on how we could do better, what kind of improvement you'd like to see. I don't know. Yeah, stuff y'all want to talk about.
Gentlemen, thank you very much for this workshop. I have the problem, which is really a user problem, I guess, because my stuff is not really production-based, but sort of like a personal use and education. And for a long time, I have two major problems. One is that not only my, experiments, also production-based radios seems to have a lot of repetition of the same material, even if the sample range is very wide. Is there a way to modify the random process or function, whatever is responsible for creating the random playlists, because it seems to pick up the same stuff more often than other? And another one is how we can start working with metadata in media tags, because the function to control playlists and stuff through metadata is already existed, but I would be very interested in not only me in examples how to do that. And that's basically two minor questions, and just thank you very much for your continuous and amazing work.
Thank you. Appreciate your question. Let's see if I can share my screen here. All right, I'm sharing my screen. So your question about playlist is a question that a lot of people have had about randomness. Sam did the implementation about the random algorithm, and I can let him talk for it. But one thing we've add is this check next function, and basically the idea is that if you're not happy with the randomness, or you want to, we have also, let me see, I think we have another one. No, that's the one. And so the idea for that function is that if you don't want a file to be repeated more than once in an hour, once in 2 hours, here you can implement that. Basically, it receives the request. With the request, you have the metadata, you have the file name, pick your ways to identify the track, and you can store the last time the track has been played, and you can return true or false. So if you return true, you mark the track as being played. And if it comes again in this function in less than an hour, for instance, you return false, and the playlist will not use it. And so that's a way to, if you want to modify the randomness algorithm a little bit to make sure it doesn't repeat using whichever criteria you have. And if you really, really want to be more serious about it, what we usually recommend is to use the request.dynamic, because with this one, you're going to change the responsibility, and you're going to tell us what is the next request. And in this way, you can implement the randomness that you care about using whatever logic you want. And Liquidsoap will just say, hey, give me the next request and play it, and just follow whatever is the best thing you want. And as I said, we want simple thing to be simple. So I think that the check next is the simplest thing. It still requires a little bit of programming. This one is a little bit more complicated. And I didn't get your question about metadata. I forgot what you said. Do you want to repeat the question?
And Romain, also you can mention play log to record when a song was last played in conjunction with check next.
Okay, there's a play log. It's in the extra API. Let me
yes, exactly.
Share my screen.
The question was, sorry to interrupt, is about to dynamically in the moment based on metadata of media files. For example, I only want to listen to music from, I don't know, 20 years ago. So I want to have a, algorithm to play just music that is tagged and is only produced in the 80s or in the 90s, because now 2027. So all this data is already existed. I personally didn't see much examples of how to do this dynamic things. I know there is something like a database to it, but it's all very murky to me. Maybe I'm missing something.
Yeah, the general idea for these things is what we call a protocol, and a protocol is like, when you say, like, basically you create your own resolution function, and it says, give me, let me see if I can put some text here. Can I write text? Yeah, you say, my protocol year equal 80s and style equal, I don't know, EDM, right? And you send that as a request, and you implement what's going to go on the other side. So the function receives those parameters, and is going to basically query whatever database you have, fetch a file, and send it to Liquidsoap. So a lot of people use that to create their own query system. I know that AzureCast has their own protocol. So in general, yes, you can look at the documentation for how to create your own protocol, and that's probably where I would start for implementing that. All right, we are getting short on time, unfortunately. Is there any other question that I can ask, or I'm going to have another 30 minutes after that where I'm going to have a lot more time?
Well, that can wait. I had a question in the chat. You mentioned compiling and the assets for OCaml5 and 4 now. I think that the one that is in Debian Beauxis is OCaml5 based. Is that right? Since we are going in freeze in a moment.
Yeah, Debian. So there are two types of assets we produce on Debian packages that are built in-house, and our packages will use 4 and 5 or 5, and you can pick.
I saw that.
Packages, the internal distribution packages from Debian are going to be Debian OCaml5. I talk with them, and for obvious reason, they don't have the capacity to support two versions of OCaml.
Yeah. Okay, and I want to say a few words, if you want, about the media library and randomness and check next. Maybe I should really do a workshop for that, but maybe you can wait a little bit later. But there is something about the community and the way people use Liquidsoap. It's for me a little bit always about a trade-off between should I just use playlists and make it work, and then there's a gap between that and doing my own queue management and my own scheduling and whatever. So there's kind of a gap here, but people could use very easily the check next function. And Sam mentioned the play log. You should be careful as well that this is gonna check next is gonna be run in the main loop. It has to be fast, and if it's fast and you're just skipping songs because they're being in repeat, you're going to see a spike in CPU, and that's not very good, especially if you already have catch-ups from OCaml 5 garbage collector. But so make sure, I should share a code sample for that. Maybe I do it on the fly afterwards. But really, there's a few things to consider, and it's not so bad. The randomness is usually said to be bad, as people say, "Oh, I've heard the same song twice today," but usually it's just a switch or the playlist that is not defined properly and not efficient enough check next filter. Yep.
Thank you. Yes, if you start skipping 10 songs, there's going to be 10 successive preparation of songs, so it's spike. And randomness is a hard problem. And also, in a normal radio, the DJs that I know in the audience, typically, one of my friends, she keeps logs about the last 3 months things she played. And then every time she wants to play a song, she's like, "Oh, I played it 2 months and 3 days ago. I cannot play it again." There's just a lot of thoughts that goes into that. And yeah, we want to solve things easily. But you're right. There's a gap between simple things and complex things here. It gets into the weed of things.